Okay, let's talk some circuit analysis. Let's start out with a simple circuit. Let's say we have a battery, 5 volts, and we have a resistor, and in parallel with that resistor is another resistor, R1. Let's just say R, and this one's R. What would happen if I measured across from this point to ground with a digital multimeter and I set it to voltage? Well, I'd be measuring off the same point across this battery, and if you just put a digital multimeter across a battery and set it to voltage, you're going to read the voltage drop across the battery, which is 5 volts. However, the current is going to come in, and some of that current is going to come through this resistor, and then some current is going to come through this resistor here. If I have a device and I have some current I going in, no matter what that device is, could be as complex as a computer, could be just a straight wire, no matter what it is, whatever current comes in is going to be the same current coming out. None of it will get stored. I mean, you'll have a capacitor maybe that's storing some power, but eventually that capacitor is going to discharge and that current is going to be released. If it gets really hot, some of that energy is going to be released in the form of heat, but on a component level at least, you can think ideally about whatever current goes into the device is the same current that comes out. So you have current coming into this block, this node right here. Some of it is going to go one way, some of it's going to go the other, but at the end, drawing a line between these two, just extending this down to get the idea in mind that the current coming into this block here is the same current that's coming out. And if these two resistors are equal, the current is going to go half of it's going to go through one resistor and half's going to go through the other. Both resistors are resisting the same amount of current flow, so the amount of current going through each one is going to be divisible by 2. So that being said, I could draw an equivalent circuit. If I had 5 volts, I could combine these two resistors into a equivalent resistor, and I'm going to call it RQ, and the equivalent resistance of two resistors in parallel is one resistor times the other divided by one resistor plus the other. Since these two resistors have the same value, it's going to be R squared over 2R. So looking at an example of that, say we have our battery here, which is a 5-volt battery, and you have one resistor in parallel with another resistor, and say you have 3 ohms, and say this one's 3 ohms as well. If the voltage drop from here to here is 5 volts, the current through this resistor is going to equal 5 volts divided by 3 ohms, and the current through this resistor is going to be the same value, because you're still reading across a 5 voltage drop across a 3 ohm resistor. So that is 5/3, which is 5 divided by 3 is let's say 1.67 amps. So that's how much current's going through each one. You have 1.67 and 1.67. So we know that there had to be 3.34 amps, just 1.67 times 2 going through the wire here in order for it to be halved going down each leg of the circuit. So let's see if my equivalent circuit has the same amount of current going through it. My claim is that the equivalent circuit would look like this. And I'm saying that it's 9/6, right? Because it's 3 squared divided by 3 plus 3. So if I say what is the current through here, I would have to have voltage divided by the resistance right? You'd get 30 divided by 9, which is roughly equal to 3.33 amps, which is basically the same. It's just a rounding error. But yeah, that's how you create an equivalent circuit.